Okay, now we've got a question on this journey. There are 3 stages to the journey. I'd suggest that you pause this, try working through it, and if you have difficulty then go back to the video. Hopefully I'll get through this quick enough. So there's a car travels along a straight level road. It's got 3 parts to the journey. Those parts of the journey are, let's number them, 1, there, 2 and 3. Now the acceleration will happen on the first part of the journey here. So that one there. We're given a velocity, initial velocity, we're given a final velocity, and we're given a time. Then it goes at constant speed. I'll just use a different colour for that one, for 15 seconds, and then it goes at decelerates again from that to rest for a distance of 45 meters. Now for these problems we really want to be thinking about the 3 equations of motion for the for constant acceleration. And these equations are as follows: v is equal to u plus at, v squared is equal to u squared plus 2as, and s is equal to ut plus a half at squared. We'll number them 1, 2 and 3. Now also notice that we've got another section in the journey here, this middle section, and in this middle section we're just going to be using its velocity is equal to distance over time. So when it's constant velocity you just use the one equation. So anyway, for part 1 what we have is v squared, well, probably look at the best equation to use, and in this case it's the first equation because we've got all the things. We've got a v, we've got a u, we're looking for a, and we've got a time. So it's clearly that's the equation we want to use. V is 30, u is 12 plus a times 6. Now we're looking for the a. Here it's the only unknown. We should be able to do that fairly okay. In order to solve an equation like this, I'll go through it the way I would always do it. So I'll just move the 12 plus 6a over to this side, because that's generally where a6, 6a, same thing. Okay, now I'm going to subtract to get the a on its own, subtract 12 from both sides. So if I put a minus 12 there, and minus 12 there, and we get 6a is equal to 18, a is equal to 3 meters per second squared. Okay, that's the first part. The second part is the deceleration, which is actually for the third part of the journey. Now again, looking at the equations, we're given the initial speed. It starts from 30 meters per second in this section to rest at a point Q, and then travels 45 meters. So you want to be looking at these 3 equations again. Well, it's a slightly different one, is more useful in this case. We will use the v squared is equal to u squared plus 2as. Now v squared is 0. You have to look at that, you have to see that when it decelerates to rest, the final velocity is 0, is equal to 30 squared plus 2a, and s in this case is 45 meters. So again, I'd bring everything over to one side, so we know that 30 squared is 900 plus 90a is equal to 0. In any of these problems here, always subtract 900, get rid of the number added to it first. Fairly basic, I suppose. And just put a minus 900 there, plus that one. Then you'd have a minus 900 over here. So you get that 90a is equal to minus 900. And what we can do then is do the same thing to both sides, divide both sides by 90, and divide by 90, and we get a value for a of minus 10 meters per second squared. Second part. Done. Now, third part is the complete distance from P to Q. Now, in order to do that, we need to know the distance for the first section. So S1 is equal to UT plus a half AT squared. We've got all of these values now. UT, the initial velocity, was 12 times 6 plus a half. The acceleration we worked out to be 3 times 6 squared. Now putting this into a calculator, just doing it in your head, you get 72 plus 108, I think, 108 divided by 2, which is equal to 72 plus 54, which is equal to 124 meters. Okay, 126 meters. I'm rushing it a bit there. Okay, now I need a little bit more room here. So continuing on with this, what we have is we've got the distances for each of the different sections. So part 3 we can now fill in. I'll just continue part 3 over here. And we've got the distance for the first section is 126. The distance for the second section is given to us as 45. And the distance for the third, that was for the third section actually. And the distance for the second section, which was where it moved at constant velocity, I'll just go back to that for a second. We can get it, he moved at a constant speed, 30 meters per second for 15 seconds. 30 meters per second for 15 seconds, so we have to use a little bit of algebra there. I'll just do that over here. So when it's constant velocity, you get velocity is always distance over time, so distance is equal to velocity multiplied by time. So in this case it's 30 multiplied by 15, which is equal to 450 meters. So I'll fill that in there now. 450 there. So total distance is equal to 6 plus 5 is 11, carry the 1, 5 and 5 is 10, and 2 is 12, carry the 1, 1, 2 and 4 is 6. 621 meters. Okay, and we're nearly there now. We're just on to the last section of this question. So the average speed of the car as it travels from P to Q. Now average speed is a formula you need to know, is equal to total distance over the total time. We've already got the total distance. Now I just want to see what times we have. So we know the time for the first section, T1, is equal to 6 seconds. It's given to us. We know the time for the third section, I believe. I'm just having a look to see that. We're told the time for the second section is 15 seconds, and then we're going to have to work out the time for the third section. So I'll just fill in that anyway so that we know that we have it. Time for the second is 15 seconds. The time for the third section, we just have to work that out. It won't take too long. Now, if we're looking for time, we could use either the first or the third one. The first one will work out easier because there's no squared in the time, so we'll use that one. So I'll fill in the numbers here to work that out now. And the equation is V is equal to U plus AT. V is 0. U is the initial velocity for the final section is 12. I believe, yeah, that's right. We know the deceleration is minus 10. Now you have to include that sign there, it's very important. And we're looking for the time. V is equal to U plus AT. Let me just double check that. Something looks a bit off about that. Decelerates from 30. Okay, so that's wrong. Why did I get that wrong? Oh yeah. Okay, So I'll just correct that. The initial velocity for this third section is not 12. So I'll just go back there just 1 second. The initial velocity is indeed 30. So that's just rushing it a little bit. Plus A, which we've worked out to be minus 10 times T. Now I'd always write this again. I know it's a bit laborious. 10T is equal to 10T plus 30 is equal to 0. Bring over the plus 30, or subtract 30 from both sides, which is the way I like to think about it. So minus 30 on that side, minus 30 on that side, minus 30 and plus 30 cancel, and you get minus 10t is equal to minus 30. Again, what we can do here is divide both sides by minus 10 and minus 10, and we get the time for the third section is 3 seconds. So we'll just fill that in now, where we have that there, 3 seconds. So total time is, add these up, 9 plus that is 24 seconds. Okay, so now we've got the total distance, total time. Let's put a little subscript on that, that's the total time. So we know the average speed is just equal to 621 divided by 24. A bit too complicated to do in my head, so we'll just do the calculator on that. 621 divided by 24, and we get 25.875. We'll just round it up to 25.9. 25.9 meters per second. That's squared anyway, meters per second. So that's it. Okay, here is the 2010 question 1 from the ordinary level paper. It's a car travels along a straight level road. It passes point P at a speed of 12 meters per second and accelerates uniformly for 6 seconds to a speed of 30 meters per second. I'm just going to highlight the information that we've got. Okay, now the first part of this question is to work out the acceleration. Now, in order to do that, you want to be thinking of the 3 equations of motion that you have to have. So you've got V is equal to U plus AT, V squared is equal to U squared plus 2AS, S is equal to UT plus a half AT squared. Now, thinking about it, we're looking for acceleration and we're given 2 speeds at a time. So this here is the equation that will best work for this scenario. So for part 1, part 1, we'll use V is equal to U plus AT. V is the final velocity, so it's 30, is equal to 12 plus AT and 6 seconds. I'm just going to put that in a different colour so we know that's the one we're looking for. AT. Now it's just simply an algebra problem. Now when I come to doing problems like this, I would always tend to subtract, bring over the 6a plus 12 over to this side. I'll just do that for 6a plus 12 is equal to 30. Now, in thinking algebra terms, I would always subtract 12 from both sides to solve this equation. So I'll do that now. Minus 12 on that side, and if I put a minus 12 and then plus there. So what you get is that the minus 12 and this plus 12 cancel, and we get 6a is equal to 30 minus 12, which is just 18, and then to solve this, divide both sides by 3 by 6, and we get A is equal to 3 meters per second squared. Now, part 1 complete. Now part 2 is the deceleration. Now we want to again look to see where the deceleration is. So it travels at a constant speed for 30 meters per second for 15 seconds, then it decelerates uniformly. Again, we're given a final speed from initial velocity, we're given a distance, and we're asked to find deceleration. So in this case, we're not given a time, we're given a final speed, we're given and it's to rest. So we're given the final speed and initial speed, and we're looking for deceleration. In this case, we're given distance, so this is the equation here we'd want to be using. So in order to do that, we will sub in the values we know. So we have v squared is equal to u squared plus 2as. Again, a is what we're looking for. It'll turn out to be a negative sign because it's deceleration, so v is the final velocity is equal to u squared, which is 30 squared plus 2as, which is 45. So bring that over, 30 squared would be equal to 900, so 0 is equal to 900 plus 90a. Again, I'm going to go through this the way I like maths to be done, which is we will subtract, bring over the 90a first, so we'll just swap it over. 90a plus 900 is equal to 0, and we might just give a bit more space here so we can see it. And so subtract 900 from both sides, minus 900 there, minus 900 there, and again we see that this 900 and this 900 go to 0, so in the next line we can just write 9a is equal to minus 900, and to solve this we have to divide both sides by 9, and we get a is equal to minus 100. Is that right? Nope. Excuse me. I'll just correct that little mistake. And of course that should be 90 there. So there should be an extra 0 there. And then we should get 90a divided by that. You'd be left with 10a is equal to 100, or a is equal to minus 10 meters per second squared. Units are very important here. Okay, now the next part of the question is to find the distance from P to Q. So let's read the question again. It passes point P at speed of 12 and then accelerates uniformly. Okay, so we know the acceleration for that. We don't know the displacement for that section of the journey. It travels at a constant speed for that for 15 seconds. And finally, it decelerates from, okay, so Q is the final point. Now, just to look at this bit here, I would say we might want to work out the distance for this little middle section here. Now, because that's just simply distance, speed and time. If you're moving at constant velocity, you get the velocity is equal to distance over time. We're given the velocity, we're given the distance, so we can work that out, and it's simply going to be distance is equal to velocity multiplied by time, which is equal to 30 times 15, which is equal to 4,500 meters. So that's our first speed, our first distance, or maybe even we call it S2, might be better. Our distance 2, because it's the middle section of the journey. We know the final section of the journey is 45 meters. Actually, have I got that wrong? Yeah, I do have it wrong. And I'll just correct that now. Out 7, when you rush things, that happens. Now we've got this, it should only be 450 meters, but still, okay. So we've got the first section, we've got the second, we've got the second and third sections. We just have to work out the first section. So to do that, right, we need to know, we'll just move this down a bit, 9. So we will use, in this case, we'll use the third equation. S is equal to ut plus a half at squared. So I'll do that now. We've got S is equal to ut plus a half at squared. S is what we're looking for. The initial velocity is 12 plus a half at squared. We've worked out the acceleration already. A half times 3, and time squared in this case is 6 seconds. So 6 squared. So we're on to the last bit here, and we can see this is equal to 12 plus a half times 3 is 1.5 times 36. I'll do it differently actually. 1/2, 3 times 36 would be 18 carried on 3, 108. And so we have 12 plus 54, which would be equal to 66 meters. Now we've got our distances. We know that we've got 450, we've got 45 and 66. So for part 3, the total distance in this case is part 3, total distance is equal to 66 plus 450 plus 45. So that's equal to 6 and 5 is 11, carry the 1, 1 and 4, 10, 16, carry the 1, 561 meters. Now we're on to the last part of this, and it's the average speed of the car. So I'm going to just write in one more equation that we need for this, and average speed is given by so average speed is equal to the total distance divided by the total time. If you just got the averages of the velocities for the different journeys, it wouldn't be a fair average speed. That's why we have to do it that way. So we know the total distance is equal to 561 meters. We know that the total time, that's the time for the 3 different journeys, is we know it's for the first section it's 6 seconds, then 15 seconds, 6 plus 15, and we don't have the time for the third section, so we have to go work that out. So I'll do that just now. So I'll use a different colored pen, just do it to the side. I'll use that one there. Again, we know everything else except the time, which would be the easiest one to work with, would probably be v is equal to u plus at. I'll just write that over here. V is equal to u plus at. The final velocity for the third section is 0. The initial velocity is 30. The acceleration is minus 10 t. Again, I would move it around, so we have minus 10 t plus 30 is equal to 0. To solve this, we have to get rid of 30 beside the number there, so subtract 30 from both sides, minus 30 there, minus 30 there, and we get minus 10t is equal to minus 30, and the time works out to be 3 seconds. So, plus 3 there, and now we have got 561 divided by 6 and 3 is 9, plus that is 24, which is equal to, I'm just getting my calculator out for that, and 561 divided by 24 is equal to 23.4 roughly meters per second. Okay, so here we have a concave mirror example. Just using PowerPoint, you can see that if a ray goes parallel, it goes back to the focal point, and likewise, a ray goes through the focal point, it comes back parallel. The image is formed here, and it's an inverted image. The next one is when you have a ray inside the focal point, now parallel, comes back straight. This is an awkward one coming up here, because you've got the ray that has to go up as though it comes from the focal point. So you can see that there, and that will go away parallel. Now these two rays will never cross, so what you have to do is imagine where they'd cross, like this, there, and the image is opposite.